So in this video, we follow up with what we discovered in the example in the previous video. The mean and the standard deviation of the sampling distribution of x bar. Suppose that a simple random sample of size n is drawn from a population with mean mu and standard deviation sigma. The sampling distribution of x bar has a mean mu sub x bar equals mu. Now this is what we learned in our previous video in the example. We found that our mean of our sampling distribution of x bar equaled the mean of the population in the first place. But further, the standard deviation sigma sub x bar, so this is the standard deviation of the x bar distribution, that will equal the standard deviation of the population divided by the square root of the sample size. The standard deviation of the sampling distribution of x bar, that is sigma sub x bar, is called the standard error of the mean. So if you see that term, find the standard error of the mean, it means find sigma sub x bar, which is equal to sigma, the standard deviation of the population, divided by the square root of the sample size. So let's take a look at an example. Suppose the mean and standard deviation of a population are mu equals 75 and sigma equals 12. If a sample of size n equals 16 is taken from the population, find the mean and the standard deviation of the sampling distribution of x bar. Now the main thing that I want to make sure that you understand before we look at this example is that we're talking about two different things, okay? We have an underlying population that has a mean of 75 and a standard deviation of 12. And so we're going to take a sample of size 16 from that population, and we want to know what is the mean and the standard deviation of the sampling distribution. So the sampling distribution is not the same as the population distribution that underlies it, okay? So based on the theorem that we just saw, we learned that the mean of the x bar distribution will equal the mean of the population, and we learned that the standard deviation of the x bar distribution will equal the standard deviation of the population divided by the square root of the sample size. Okay? So for our sampling distribution, the mean of the x bar distribution is going to equal the mean of the population, which is 75. So the mean of the x bar distribution is 75. The standard deviation of the sampling distribution of x bar is going to equal the standard deviation of the population, which is 12, divided by the square root of the sample size, and the sample size is 16. So we're going to divide by the square root of 16. Now the square root of 16 is 4, so we have 12 divided by 4, and 12 divided by 4 is 3. So our sampling distribution of x bar will have a mean of 75 and a standard deviation of 3. So again, we have our underlying population, which has a mean of 75 and a standard deviation of 12. Our sampling distribution, which comes from that population, will have a mean of 75, but its standard deviation will be 3.